Okay, so where we left off last class was doing integrals, but with u substitution. When it's a little more complicated, that's when we use u substitution. So in this problem, the original problem was 5x squared over x cubed plus 4 squared dx. And you could totally do it as is, no problems, no worries. But sometimes it's easier to rewrite it so they're next to each other. So 5x squared, x to the third plus 4 raised to the negative 2. Positive 2, when you move it up, becomes negative 2. Either way is fine, same thing. Okay, so this one's a more complicated one. So we're going to use u substitution. Now remember, u could be anything, but only one u pretty much is going to work. So u is going to be x to the third plus 4. Why? I don't know how to do stuff raised to the negative 2. And if that became u, life becomes easier, number one. Number two, when you take the derivative of u with respect to x, you get 3x squared, x squared, x squared. That's a little hint that that derivative is also going to help me. Then, to save a little bit of the algebra, remember it's always dx equals du over 3x squared. Now, we did a bunch of problems last time. This is just going to be the same old, but be careful. What happens a lot of the time is it's the details that catch people. So right now, complicated. If I do the correct u substitutions, it should be not as complicated. So if I take the integral, I don't have anything for 5x squared. Instead of x to the third plus 4, that becomes u to the negative 2. And instead of dx, that becomes du over 3x squared. Now, a couple things. Number one, it looks more complicated. We have x and we have u. But if we did the correct u substitution, what will end up happening? This will simplify nicely. X squared over x squared is 1. We have not, let me say that out loud and clear. We have not taken the integral. I'm left with 5/3 u to the negative 2 du. A common mistake, which is the big mistake, is just to put plus c and call it a day. You never took the integral in an integral problem. All we've done is simplify it, so now I can. And yes, there's a fraction. Yes, there's a negative. It's okay. They're just like everything else. There's only two special cases, and the special cases are e to the x and -1. That's it. So if I was taking the integral, 5/3 stays in front. How do you take an integral? Add 1, -1, divide by -1. Don't forget your plus c. Now, people say, oh, -1, that's a special case. We're not taking the integral twice. We're only doing it once. So we took the integral, we're done. That's it. Now we're going to clean it up. 5/3 times -1 is -5/3. I can make that u1 go to the bottom, so it's a +1, plus c. And I don't want my final answer in terms of u, so I'm going to go ahead and change this to 5/3 instead of u. X to the third plus 4. Don't forget your plus c. Okay, we're going to pause right there, see if we have any questions. So that is a little refresher of what we did last class, but I do have to point something out. I'm going to put a line. I'm going to put a bunch of stars, bunch of stars, bunch of stars, bunch of stars. And every problem we have done up to this point, if we've done it correctly, has worked out nicely. Will everything work out nicely? No. But the good news is we're going to call this a special case. This does not happen all the time, but it can happen. This is a special case. Okay? So the question is, what happens if it doesn't work out nicely? Do I just give up? Maybe you can't do it. Yes, there's other things like integration by parts that you can do. We're not going to go that far, but I do want to show this one. There is a workaround. And again, it's if the u substitution doesn't work nicely and it's still possible, this would be the way to do it. Okay? So why is this a special case? Let's do this totally together. First of all, is this a basic one? Or is this a little bit harder one? What do you think? Basic or harder? Basic means you just add one, divide by it. Harder means you need to do u substitution. This is going to be a harder one, right? So if it's a harder one, we're going to do u substitution. Just call it out. What do you think the u is going to be? Perfect. It's going to be x plus 6. Now, again, you can make u whatever you want, but the only one that's going to work is x plus 6. Then, let's keep going. Du over dx. The derivative of 1x is 1. Derivative of 6 is 0. Cross multiply. You get dx equals du. You're like, that's a little strange. And it is, but it still works out. And when I make my u substitutions, you're going to have x, you're going to have u raised to the 8, and you're going to have du. And then you're going to be all excited, waiting for the fun part where you simplify and it looks nice. And that doesn't happen for this one. Okay? So now you're like, okay, it just doesn't work. It can work with a little bit of, what's going to be the magic word? Algebra. Algebra, algebra. Okay, so at this point, you may give up and think you can't do it, but you actually can. And the reason why you can is when I manipulate a little bit more, you'll see it will work out. What do I mean by that? Well, my goal is to go from x to u, and it didn't work. I got u and I got x. I'm trying to get just u. So again, special case, don't freak out, don't worry. Remember, u equals x plus 6. That's what you told me. Can I also subtract 6 from both sides and say that x equals u minus 6? Isn't that true as well? And if that's true, then instead of x, I'm going to put u minus 6. Okay? I'm going to pause there just for a second. And you're like, I don't know if I like this. But did we go from x to u? Did we go from x to u? We did. No more x's. Now we're in u. But now you're a little worried saying, I don't think I can do this one. But you didn't clean it up yet. Be careful. I haven't taken the integral. If you distribute the u, this becomes u to the 9 minus 6u to the 8 du. So did it work out? Yes. But in order for it to work out, we had that extra step, that little bit of algebra that got us to putting in terms of u. Now I'm going to pause there. Have we taken the integral? No. Take the integral, substitute in, get your final answer. So remember, that was just a substitution. We still have to take the integral. So the integral of u to the 9 is u to the 10 over 10. The minus 6 stays in front. The integral of u to the 8 is u to the 9 over 9. Don't forget your plus c. This will clean up to 1 over 10. And instead of u, that's x plus 6 raised to the 10. Minus 6 over 9 simplifies to 2/3. X plus 6 raised to the 9 plus c. Now, I could simplify a little further, but I'm not going to worry about that. We'll just leave the answer just like that. But could I factor out an x plus 6 to the 9? Yeah, But I'm just going to leave it like that for now. It is pretty simplified. So we've been spending a lot of time on how to take a u substitution, but we haven't done an application problem with u substitution. So here's our application problem. And remember the point of antiderivative integrals. A company finds that the marginal price, stop there. Marginal means derivative. So they're not giving you the original, they're giving you the derivative. They're giving you the marginal price. Are we okay? And this is supply at X bottles of baby shampoo per week. So here you have a derivative. And that is for price, marginal price, 300 over 3x plus 25 squared. Now, that's great. You gave me marginal price, but what I want is price. So how do I go from marginal price back to price? What are you going to do? Integral. So why do we take the integral? Because we're starting with the derivative. We're starting with the derivative. and we're going to original price. So we're going to take the derivative with respect to X. Now, yes, you can leave it like that, or like we did in the previous example, you could rewrite it, bring that positive 2 up, and it becomes negative 2, and I'm going to stop there. Now, at this point, it's a more complicated one. So you're going to do U substitution. But I'll give you the little hint. It's actually a really nice U substitution. It's going to go faster than you think. Okay, but it is U substitution because I have two things being multiplied, because I'm being raised to the negative 2. So it is a U substitution, but it will work out nice. So all I want you to do is the U substitution, get the equation, and then we'll talk about the second part with the 75 bottles and $160 per bottle. So notice it's a little more complicated. So it's going to be U substitution. The U is going to be 3x plus 25. 3x plus 25. Then when you take the derivative of U with respect to X, you just get 3. Okay, we'll deal with that. 3 is 3 over 1, cross multiply. This is going to be dx equals du over 3. Okay, so we pause there, Now we're going to do our U substitution. I don't have anything for 300. Instead of 3x plus 25, that becomes U to the negative 2. And instead of dx, be careful, it's du over 3. du over 3. Have I taken the integral? No. Have I simplified it? No. What do I mean by that? Well, 300 divided by 3 is 100. So I have 100 u to the negative 2 du. Okay, so it does clean up pretty nicely. And then I have not taken the integral. So when I take the integral, the 100 stays. Add 1, you get negative 1 divided by negative 1. Don't forget your plus c. Now, watch how I clean this up. 100 divided by negative 1 is a negative 100. That u to the negative 1, I'm going to move to the bottom. And then I don't want this in terms of u. I'm going to put, instead of u, 3x plus 25 plus c. So that becomes my so far, not done yet, but so far answer. The issue we have at this point, people, okay, we had marginal price. Now I have price to be negative 100 over 3x plus 25 plus c. But then everyone's going to ask, what's c? You can't just put plus c plus some number. It could be positive, it could be negative, it could be small, it could be big. I need to know what c is. So part of the problem, bless you, is that they told us 75 bottles, which is X, has a price of 160. So they gave me information about price. And the reason why they have to give me information about price is so I can figure out what C is. So again, in the problem, X is 75, P is $1.60. So I can now put price is $1.60 when X is 75. So I can do the work to find C. So that becomes a 160. This would be, trust me, if you did 3 times 75 plus 25, all of that is going to be 250. So we have negative 100 over 250 plus C. Negative 100 divided by 250 is negative 0.4. So if you add 0.4, add 0.4, C equals 2. So now I figured out what C is. Now I can give you your complete price function. It's negative 100 over 3x plus 25, and we found that C is 2. Now you tell me how many bottles, you plug it in, and I'll tell you the price per bottle. You tell me how many bottles, I plug it in for X, and I'll be able to tell you the price per bottle. Okay, so to kind of walk through what we did, we started with marginal price. We wanted to work backwards, so we found the integral. In order to take the integral, we had to do u substitution. Once we did u substitution, we realized there's a plus c. We got to figure out what the c is. So we used what was given. X is 75, price is $1.60. We plugged it in, we solved for p, and now we have a complete price function where you tell me X, and I'll tell you the price per bottle. That ends 5.2. Now, in order to do the last section, 5.5, you need to know 5.1 and 5.2. So let's see if you remember 5.1 and 5.2. So I want you to take the integral of 3x squared minus 2 e to the x plus 3 over x. Now, if you want to rewrite that, you can. Dx. That's 1. And take the integral of x over x squared plus 10, which if you want to rewrite it, you can, but you don't have to, dx. Okay? And the only hint I'll give you is the one on the left is a basic one. The one on the right is going to be a u substitution one. Okay? But you should be able to see that right away. So see if you can do both problems. So we have two examples. The one on the left is a straightforward integral, let's say, and the one on the right would be a u substitution one because it's a little bit more complicated. Now, remember, if you want to rewrite it, it's always a good idea. This would be 3x squared minus 2 e to the x plus, this is x to the 1, move it up, x to the negative 1 dx. If that helps you to rewrite it, please rewrite it. Then, since they're being added and subtracted, we take the integral of each one. The 3 stays in front. This would be x3 over 3. The 2 stays in front. E to the x is a special case. The integral of e to the x is e to the x. The 3 stays in front. X to the negative 1 is a special case. Why? If you add 1, you get 0. Then dividing by 0 is a problem. And that was our other special case, ln absolute value of x. Don't forget your plus c. And then I would clean this up by saying x to the third minus 2 e to the x plus 3 ln absolute value of x plus c. And that would be a little review of the first section. Second one's a little more complicated, so we're going to do u substitution. Again, you have to be careful and know how to do it, but the u that's going to work is x squared plus 10. The derivative of u with respect to x is 2x. And then dx equals du over 2x. Now, should you rewrite it or leave it? It works either way. If you want to rewrite it, this could be rewritten as x times x squared plus 10 to the negative 1. If you wanted to rewrite it first, you can. I'll just leave it the way it is just to show you that you're going to do that either way. So this will be x over u dx. du for 2x, but be careful. Am I left with 2 or 1/2? There's a 1 over 2, so that's 1/2. X divided by x simplifies, and then this is u to the 1, so it moves up u to the negative 1. Okay, I haven't taken the integral yet. I just did the u substitution. I haven't taken the integral yet. I'll pause and give you a chance. If you didn't get that, take the integral. What happens? The 1/2 stays in front. The integral of u to the negative 1, that's a special case, would be ln absolute value of u plus c. But again, we don't want it in terms of u. We want it in terms of x. So it's ln absolute value of x squared plus 10 plus c. So again, yes, they had some special cases in there. Yes, they had some special cases in there, but that would be the integral for both of them. Now, that's review because these are called indefinite integrals. Indefinite integrals means there's no beginning, there's no ending. It's indefinite. It just keeps going forever. No beginning, no ending. And you're like, what are you talking about? This integral symbol can be a definite integral with a definite beginning and a definite ending by adding numbers. So if I put a 1 to 3, or if I put like a 0 to 5, now these become definite integrals with a definite beginning. This is called the lower bound. And a definite ending. This is called an upper bound. Now you're like, what the heck do they mean? We'll get to that. We'll get to that. Before we talk about what they mean and why in a word problem, let's talk about how to deal with it. Okay. Step 1, you take the integral. So if you don't know how to take the integral, we're stuck. We don't know what to do. So step 1, you take the integral. And then today's lesson, what do you do with those numbers? And that part you're going to like. What you do is you substitute in the top number, 3 to the third minus 2e to the third plus 3 ln of 3 plus c. So you plug in the upper bound, and then you subtract, plug in the lower bound. So 1 to the third minus 2e to the 1 plus 3 ln absolute value of 1 plus c. So all you're learning today is, what do you do with the numbers? And the answer is you plug in the top one minus plug in the bottom one. That's all you're learning right now. Okay? You're like, why? We'll talk about the why later when we do a word problem. Okay? So one little shortcut that I want to show you, but to be very clear, integrals always end with a plus c. Are we okay with that? Always, 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 always. But notice what's going to happen. What's c minus c? 0. So what will always happen to that constant? It's always going to go away. So you're going to notice that I'm not going to put the plus c. Not that I'm being lazy, not that I forgot, but I understand what will always happen to the c when you have c minus c. 0. So yes, the c belongs there. But you're going to notice I'm not going to put that anymore because it's going to go away. C minus c is 0. Now, the part that you're not even thinking you should worry about is that, do you know how to type this in? So I want you to type this in, get the first number, type this in, get the second number, subtract them, and get your final answer. If you plug in this side, I'm going to give you a little bit of hints. Yes, you can plug it in exactly how it is. Yes, you can do it in pieces, but I would do a little bit in your head. What do I mean by that? Absolute value of 3 is what? 3. Absolute value always comes out positive. So I'm not going to look for ln absolute value of 3. That's too much. I know the absolute value of 3 is 3, right? So I don't have to worry about that part. So when I go to the calculator, I'm going to put in parenthesis 3 parenthesis raised to the 3 plus 2e to the 3 plus 3. Oh yeah, thank you. Minus. Thank you. Minus plus 3 ln of 3. 3 ln of 3. Again, I'm not putting absolute value of 3. You can. It's in the calculator, but absolute value of 3 is 3, right? And you will get on that side negative 9.88. Negative 9.88. So that is negative 9.88. It's always minus. It's always minus. And let's type in the other side. Now I'm going to be a little lazy. Watch what I'm going to do. I'm going to hit second enter. Give it back to me. And everywhere I plugged in that 3, I'm going to plug in a 1. I'm going to be a little lazy. And that was second enter, second enter, second enter. And when you do that, you get negative 4.44. Negative 4.44. And again, if you want to do a little bit of work, this would be negative 9.88. Negative and negative is positive. 4.44. You can do that in your head, do it in the calculator, whatever you want, but you get negative 5.44. So in summary, what are we learning today? How to deal with the numbers. What do you do with those numbers? You plug in the top number, minus, plug in the bottom number, and subtract. We're going to give meaning to all this really, really soon when we do a word problem. But it's how do we deal with those limits? Plug in the, after you take the integral, plug in the top number, minus, plug in the bottom number, and you end with an answer. Now, all this work, what if you messed up? Is there a way to check it? And the answer is yes. Because we have numbers now, we can do the whole thing in the calculator. So let me show you how. So we did it by hand. Let's check it. So in the calculator, you're going to press math, math, math. And you're going to go down to number 9. Number 9, number 9. Number 9 says function integral. Integral. So choose number 9. Now, it depends on your calculator. If your calculator looks like mine, it's going to look like the problem. If your calculator says F integral parenthesis, I'll show you that in a minute. But if it looks like this one, you literally type in the original, the very original. 1 to the right, 3 to the right, and then the inside was 3x squared minus 2 e to the x plus, and again, you can do 3 over x or 3x negative 1, your choice. I'm going to put 3 divided by x. And then at the end, it wants an x. At the end, you put the x. At the end, you put an x, enter, and you get the same answer, negative 5.44. Now, if your calculator looked a little different, if your calculator said like f of n, int, and is waiting, what is it waiting for? It's waiting for the original, 3x squared minus 2 e to the x plus 3 over x, comma, x, comma, lower number, comma, upper number. It's all the same stuff, just in a little different order. The original, comma, above the 7, x, comma, always lower, comma, upper, and you'll get the same answer, negative 5.44. Basically, what we're learning is after you take the integral, plug in the top number, plug in the bottom number. So in the second example, it's 0 to 5. So I want you, practice. We're going to plug in the upper number, 1/2 ln absolute value of 5 squared plus 10. Again, maybe do part of it on your own, then use the calculator. We're not going to put the plus c because we know what's going to happen to that plus c. It's going to subtract out. And then the bottom number, 1/2 ln 0 squared plus 10. Find the answer, subtract them, get your answer, and check it in the calculator. Now, you could type that in all you want, exactly how it is, but I would do a little bit of work. This will be 1/2 ln 5 squared is 25, 25 plus 10 is 35, absolute value of 35 is 35. So I would make it a little bit easier on you. Minus, this will be 1/2 ln, 0 squared is 0, 0 plus 10 is 10, absolute value of 10 is 10. So that's a little bit easier to type in than trying to type that all in at once. So 1/2 is 0.5, so 0.5 ln of 35. That first number gives you 1.777, so maybe like 1.78. Minus 0.5 ln, ln of 10. Again, you could just type the whole thing in if you want and get the final answer. Totally up to you. Just be careful. 1.15 You subtract them. 1.78 minus 1.15, you get 0.63. So when I go to the calculator, you should get 0.63. Now remember, in the calculator, we literally just type in the original. It is the original, the original. So you can do these problems on any work, typing in the original. Be careful when you type it in. Be careful when you type it in. So for example, if you want to type in the original, math 9, it goes from 0 to 5. And the very original that I gave you was x divided by parentheses. Those parentheses are going to matter. X squared plus 10, close parenthesis, and then end with an x, and you should get 0.63. Everything works out. So that gives you a really quick introduction of what 5.5 is about. Now 5.5 again deals with indefinite integral when you have numbers. We're going to focus more on the business applications of this, but another application is finding the area under a curve, finding the area under the curve. So you'll notice there'll be some examples where you're finding the area under a curve, but what we're going to focus on are the examples that deal with the business examples. That's what we're going to focus on, okay? But another application of integrals and from a number to a number is the area under a curve, okay? So let's get to our first example, and you're going to hopefully understand why we do it. We've been spending so much time on how, now we're going to talk about why. So a management service found that the maintenance cost dollars per year. So hold on a second. This is not just cost. This is dollars per year. Is that cost or is that marginal cost? Marginal cost. So you're given a derivative for cost of maintenance, and I want to know not the rate of change. I want to know total cost. This is where it gets a little tricky. At the end of the second year, that is a weird way, end of the second year, to say year 3. It's just a weird way. The end of the second year is year 3. The end of the second year is year 3 to the end of the 7th year, which is 7. I know that sounds weird, but end of the second is the beginning of the 3rd. And at the end of the 7th, you've completed the 7th. Okay? All of that to say, do we want the derivative or do we want the original? The original. So how do I go backwards? Integral. So in this problem, you're given a derivative and we got to work backwards. So we're going to take the integral. And after I take the integral, I'm going to go from marginal cost to total cost. Are you with me? And I want to find out the total cost from year 3 to year 7. So don't get lost about the end of the second, end of the 7th. We'll reason that out. But let's say you're given 3 to 7. So what does this mean? You're given a marginal cost and we need to work backwards. That means integral. When I take the integral, I'm going to have the cost, not marginal cost, the cost. And then I don't want the cost for all 7 years. I only want the cost from year 3 to year 7. So bottom line, there's your problem. Take the integral, plug in the numbers, check in the calculator. So again, the main idea is we're starting with marginal cost. We have to work backwards. That means take the integral. And then when we take the integral, we'll have total cost from 3 to 7. So when we take the integral, the 90 stays. This will be x to the 3rd over 3. The integral of 5,000 is 5,000x. Don't forget at the end to have a plus c. When I simplify this, we will have our cost 90 divided by 3 is 30, x to the third plus 5,000 x plus c. Now, I'm well aware that there's a plus c at the end, and yes, the plus c should be there. Okay, so that's the integral. But we're taking it a step further by having a definite integral. Now that you have the total cost, I want to go from year 3 to year 7. So if we kind of think about this, hopefully it will kind of click and make sense. If I plug in 7, 30 times 7 to the third plus 5,000 times 7. Again, I'm not putting the plus c because I know c minus c is 0. That will give me the total cost for all 7 years. And that's not what I want. I only want from 3 to 7. So we're going to subtract out the first 3 years. 30. 30 times 3 plus 5,000 times 3. Okay, now to save a little time, again, please be careful typing it in. Please be careful with all that. If you typed it incorrectly, you'll get 45,290 minus 15,810, which will leave you with 29,480. That is the total cost. This was for maintenance for year 3, which is the end of year 2, to year 7. Now, check it in the calculator. Make sure you get the same answer. And remember, when we check it in the calculator, it literally is the original. So we go to the calculator. Again, know how your calculator works. I'm going to hit math 9. This one looks like it is, so it's 3 to 7. You plug in the original, which was 90x squared plus 5,000 dx, and you should get the same answer. 29,480. 29,480. Okay, so again, you can already tell the future. This is a straightforward one. What's next? The U substitution one. So the next problem we're going to do says an amusement park company manufactures X HD TVs per month. Nope, hold on. Number 5. Number 5. That was a circle. This one. Okay. Let me kind of separate this out. Company manufactures X HD TVs per month. So look at it. It's TVs per month. So they're giving you a derivative. They're giving you a rate of change. How many TVs they sell per month. So they're giving you marginal profit. Oh, no, I don't want to do that one. Hold on. The one I want to do is this one. Hold on. Sorry about that. I want to do this one. We're going to look at revenue. Okay. Sorry about that. So basically, this is the revenue for an amusement park. But notice it's the derivative of revenue. It's marginal revenue. I want to work backwards. And I want to find out original revenue. So to do that, it's 7.5 e to the negative 0.5 t dt. The reason why we're using t now is t stands for time. Are we okay? Now, in order to, when we take the integral, we're going to go from marginal revenue to revenue. And then I want to know how much did this theme park make from 0 to 6 years. From 0 to 6 years. Now, I'll give you a little hint. I don't know how to take the integral of e to something. I know the integral of e to the x is e to the x. So is this going to be u substitution? Yes. And what would the u be? Negative 0.5 t. So I'll give you that little head start. Why? I don't know how to take the integral of anything except e to the x. So if that becomes e to the u, the integral of e to the u is e to the u. Okay? So give that a try. So if I was going to take the derivative of this with respect to t, technically it's t, the derivative would be negative 0.5. So dt equals du over negative 0.5. So when I do my substitutions, it goes from 0 to 6, 7.5 e to the u, and dt is du over negative 0.5. So if I the integral of 0 to 6, 7.5 divided by negative 0.5. 7.5 divided by negative 0.5 gives you negative 15. So that would be negative 15 e to the u du. Very important question. Have I taken the integral yet? No. When you take the integral and the du all goes away. The negative 15 stays. What's the integral of e to the u? E to the u, don't forget your plus c. That's the integral. Ends up being the same because it's e to the u. Then we're going to go back to, instead of u, we're going to call it negative 0.5t plus c. Okay, now that's the integral portion. That's the integral portion. Now we're going to plug in the 6 and we're going to plug in the 0. So if I plug in the 6, that's negative 15 e to the negative 0.5 times 6 minus plug in the 0, negative 15 e to the negative 0.5 times 0. Again, people have problems typing it in, and you don't have to type it all in. You could do a little bit of work ahead of time. So for example, negative 15 e, negative 0.5 times 6 is negative 3. That may be a little bit easier for you to type in. Minus negative 15 e, 0 times negative 0.5 is e to the 0. That may be a little bit easier to type in. Okay, so you don't have to make it as hard as possible. Make your life a little bit easier if you're worried about typing it in, parentheses, all that. So if we add negative 15 e to the negative 3, that would give you negative 0.75, negative 0.75 minus negative 15 e to the 0. E to the 0 is 1. I'll just still type it out. You get negative 15. Negative and negative is positive. You get $14.25 thousand. And that's from year 0 to year 6. Okay. Now, I'm going to give you a preview of the last part. We're not done yet. There's a very, very small part that I don't want to push today. We'll do it next class. But to finish this problem, let's check it in the calculator and really explain what it means. So if I'm going to check this in the calculator, we literally plug in the original. So I go to the calculator. I go to math. Math 9. This is from 0 to 6. Plug in the original 7.5 e raised to the negative 0.5 x, and with x. And you should get 14.25. Now, what we just found was the total revenue for all 6 years. What we just found was the total revenue, $14,253 or whatever, was the total revenue. Are we okay? The last part, which we're not going to cover, but I'll just give you a hint. The last part would say, oh, different question. What if I wanted the average over 0 to 6? So you found the total 14.25. If I wanted the average, what would I do to that number? Divided by y6. 6 years. 0 to 6. How many years have gone by? 6 years. So the last part is if I ask for average. Ask for average over the 6 years, you would take that number and divide by 6. That's why I just want to show it to you, but it's not going to change the world. It's not going to be anything weird. I just want to spend a little time on that because we're also going to practice this in that problem. But if it had the word average, that would be the $1,000. That is the average over the 6 years. Okay. So the last thing I want to end with, and then remember, we have a little bit left next class, is just practice the calculator one more time. Put this in the calculator and see what you get. Put that in the calculator and see what you get. So last one, just to remind you, you can use the calculator, but you have to be careful typing it in. And then again, the only little bit left we have to do is average, but all that means is do what we've been doing and divide at the end by how many years. But I want to use that to practice a little bit more to see how much we remember. Okay, so if you put that in the calculator and you're comfortable with the calculator, you would have gotten math 9 from 1.5 to 4.3. Again, getting comfortable. X divided by ln of x. Again, with parentheses, if you open it, you should close it. Open parenthesis, close parenthesis, open parenthesis, close parenthesis. And if you got 8.02, you did it correct. 8.02.